Hello everyone, so welcome to another development session on the NervLand project. So last time we were working on many different things, mostly trying to build some kind of Lua layer to handle the Qt event appropriately from a dedicated thread. I made quite a lot of progress on that. I think that basically we were focusing on those 2 points during the recording, and then I was working on additional points that were not recorded, unfortunately. So yeah, I made a lot of changes. And the current version that we have is a bit interesting because it's working appropriately. We can create a thread like that, a Lua worker using dedicated Lua state, I mean, and we will be moving that on the thread. Then we start that, and when we receive a message from the worker, we are going to display this message on the current thread, the main thread that we have for Qt here. So on this Lua state, actually, the message will come from another state, and in fact that other state is going to execute this script. So we can have a look at this one. Maybe we have a dedicated import worker starting to have quite a lot of folders. So this would just enter an infinite loop waiting for the thread to be interrupted. You can actually get the thread from the current worker or from the current thread, and you'll be actually performing REST request here to get some price information, and you will just send this back on the main thread. So this is kind of working nice. And yeah, from that point I actually decided I should try to improve a bit on the mechanism I have available to pass data between those threads, and so between the Lua states. So I think I have a bit more details in there. So lately I was trying to focus on that. With Qt, yes, I think we have a kind of mechanism where we can have a centralized event manager class or system, and we'll be able to register any kind of event on that. I've done that somehow in Python already, so I think I can reproduce that in Lua with what we have already. It's just that in Python, you have this object class, so you can just send any kind of dictionary anywhere, and that would be pretty easy, which is not so straightforward in C++. So I decided I should try to give another chance to my data map implementation, which is something I'm using in other projects. And this implementation was a bit dirty actually, but I've been refactoring that, so it's looking a lot better now. Where do I have that? You can go in data map. It's still a map which is using strings as keys, which is something I don't really like. I mean, from a runtime perspective, if you want maximum efficiency, you should probably avoid strings. So the idea would be to eventually start using string ID instead, which are integers. But I think going to make that another kind of data map. I would be maybe making a generic template version of it, and so you would have a simple data map which you can use for simple configuration stuff and things that are not dynamic and not executed at runtime or stuff like that. And then I would have a fast data map in case this could be needed, where the keys would be string IDs instead. But that's another concern for now. We're just focusing on this initial version of data map, and it's using boostini for the storage, and we already have kind of quite a lot of storage support. We can support string, bool, all this, vectors. Oh, okay, that matrices and important also here. And then I was working on support for reference object classes. So you could add a ref object or another data map itself. And now I'm actually focusing on the support for vectors of any kind of object. So I was working, yeah, but referenced vector, by the way, not just ordinary vectors. So I've been working on providing only the support for referenced vector of bools or referenced vector of float 32s. And this then brings me to the referenced vector class itself. And this is where I'm starting to have a very interesting concern. This is the first case where I thought, okay, maybe I could use multiple inheritance here and just add the vector as another inherited class, which I don't really like this idea, but at the same time, that seems that it's not absolutely dirty, so it seems somewhat appropriate to do here. If you just want to store a reference vector, you might just as well have your vector here as part of the class inheritance classes. I mean, inheritance tree. So, all right, but then we got to the point where we had to generate bindings for that. And this was really funny because for class templates, I was basically not supporting base classes at all. So when we were doing that instantiate in class, we would come with a given class. So that class would be, for instance, ref vector of bool, and you would notice that it comes from this class template here. So you would request that this class is filled up with whatever we have in the class template. So you would actually just handle the function that were available in the class template and inject those functions in your class. But what I've been adding is this part to provide the support for also handling the bases. At first, I was just handling class bases. So if we go in, where do I have that? Let me see the source. Yeah, the core threads, I guess. Where do we have ref? No, not here, please. Ref vector of bool. Yeah. So at first, when we were producing those Lua threads, there was no parent found at all. So that was a problem because then you could not really use this command base. So when adding the support for classes, we could get this one added. And then I decided, okay, I should push this even further and add support for template bases. And so those template bases may need to be instantiated also when you have to bind the corresponding class you're binding here. So you would basically, in this case, figure out, okay, your template base is using this list of arguments. So in this secondary case, you know that it's a template, class template. So you would try then to do a remapping of those arguments. You check if that class doesn't already exist, and if it doesn't exist yet, that's where you would create the corresponding class. And you would then be able to assign an actual class generated from your class template as a base for the class that you are binding. Okay, so that's how we eventually got this additional base class here, and so it knows now that we have this as a base, and it's also producing the bindings for this base class. So we have this base class, where is that? We have NV vector of bool, vector of bool. Okay, so there's no convenient name on this one yet, but eventually we can add that. I guess we also have another, well, no, not this one. Where is I need the core one. For the float, for instance, yeah, we also add those additional convenient names that are used instead of the full name when they are available. So we need maybe to define more of this. But anyway, this was for the core module, but then I tried to generalize that and try to run the same thing on the Qt module. And in Qt, we get to cases that are going to be a bit more complex. So, for instance, we have cases where we do inherit from integral constant. So, where do we have that? Here, for instance, we'll be adding this base, this template base, std integral constant into Qt private built-in meta type. So first thing I'm noticing here is the namespace is not correct. So that's not good. It's producing, so let's see, we have that here. It's producing something using the Qt namespace, which is not wrong. We should be in std. So there's something not good going here. And I need to, yeah, also the name here is strange. But I think that's because when I am to, where do I do that? I don't remember. Okay, let's go back. No threads, core threads. Let's keep this one. When we have to write this text, basically, so we do that in the register package writer. Here we get all the base names to write them, and those base names, they are coming from here, a concatenation of this base name list. And the base name list, that's something you get by iterating on all the bases that you have in your class, and you just get the Lua name for it. Except that we still have cases now where this class object here could actually be a class template. It's still considered a class because class templates are class in my system, but it's not something you could use directly. So there's something not quite good here. And so we'll need to be handling this get Lua name. Basically, there should be no case where you would need to call that on the class template, because you definitely need to instantiate the class template first to produce a real class. So this was actually what I was considering doing here. So I've just prepared this instantiate class method in the class template, where you would provide a list of template arguments to perform the instantiation. First thing I'm considering is in the Lua C-line parser, sorry. At this point here, you know, we might be trying to figure out, okay, do I have with considering a base? So we would say, okay, do I have a real class for that already? And if we do not, then I'm going to check if the syntax that we have is a template name. So we could have something like we have like what we have for the integral constant. Actually, let's just keep those files up to not do them again. and close what we don't need. Okay, so we're just here. And what do I need? I need the bind qt. So bind qt, you see, for instance, here I'm resolving this std integral constant with the argument int and 0. So it means it's not really a template anymore. It's actually a template instantiation. So what you could have here is, for instance, std integral constant of int in 0. If you do that, you would still be able to resolve this as a template name, and the arguments would be int and 0. Actually, we should probably check that. Yeah, when you do the resolution, I should trim the spaces like what we have here. So let's try to fix that first. Come on. Just copy that, please. So the implementation is in Lua Manager. So you would split the args. All right. And next, can you trim the spaces? Do you have something to trim the spaces? Let me try to figure out. So let's just create a new. Well, that's on your occurring. Yeah, okay. Let's create a new array, which will be the result, final result that will 10. And what we need to do is to iterate on all the argument that we have. And we'll need to add that into the final array, but we need to trim the spaces. I don't know what function I can use for that, so I need to figure out. And then that's what we should send back instead of the default args table. So trim, let me check where I have that. Okay, so we seem to have this string x module with a strip function. So I guess we can use that pl string x. So in Luna, let's import this one. So by using this, normally, okay, I just added this line, I believe, right? So we just added this comment, importing this module and using it. And class template, yeah, I'm preparing that. So everything should still work. Let's just try to rerun the binding generation for Qt. That's taking about 10 seconds normally. Okay, so if yeah, and this one is always changing. I'm not quite sure why. There's something, I don't know, random about that. Anyway, in there where we have the report for integral constant, now we don't have the space anymore, so that's good. But so the concern, let's make a comment, maybe trimming, not this one, but this one. Oops, no. You don't, no, cancel that. Yes. Right. So in there, the thing is, when you get to this point, you will get a template class. Here at least. When you have a template class, you can retrieve that template class, and if it doesn't exist yet, you can try to create this template class. Get template class by name. Yes, I think that should do the trick. And eventually your TPL here would be a template class, a valid template class with template arguments. Then what we do is, at this point, we add a template base to this scope, which is the class that we are currently passing. Except that this class here could be either a class or a class template. And if it's a class, there's no way you could be adding a template base, because it's not template, that doesn't work. So we need to figure this out. So if we have a real class, then we really expect to have a fully I don't know, qualified, a fully instantiated what does it mean to have a fully instantiated template? It means that all the template arguments should really be valid types that are already defined somewhere or exist as built-in types. We could check that, or for now we could just assume that this is true, because otherwise we would need to check that we have the type for int or the type for 0, and that could be more generic than that. You could have type for true, but these are all string for now, so figuring this out is a bit tricky, I guess. But so what I need to do is just check if the scope is class, then what I need is to instantiate this template that I just prepared or discovered. So we'll need to create a base class from that. So base class, and that would be something like template class, instantiate class. That's where we need to do this instantiation. And you would provide the argument that you want to use for the instantiation, which is exactly the list that we retrieve here. So that would contain int and 0. So you provide those args. Yeah. And that is the base class that you would add to your scope, your current scope. So you would still do scope add base and not template base, and you would provide base class. Come on. The visibility, I don't know what this is. Yeah, we retrieved that before. No, we did not. Where are we retrieving visibility? Guess it's available anyway. Yeah, that's a bit more generic. It's retrieved before that. We're retrieving virtuality also here, if it's a virtual base or not. So we can use those two elements to add the concrete base, except that this function here we need to implement. That's what I was thinking of doing here. Okay, and then here's another case, which is when the scope is actually a class template. And if it's a class template, what we really expect then is to have, you know, the base could be something like nv vector of t when we are defining, for instance, so let's make an example. Ref vector public. So that would be we need a template definition on top of it. Template type name t. So that's a simple case that we may have to handle. We're defining a template, which is a ref vector with the template parameter t, and then we find this base. So here we'll get nv vector, and the list of argument will just be t also. So we really expect to have a match between those templates. So we could have maybe, I don't know, template, the byte name u or whatever, and then that could be t and t or something like that. So the list here could be different from the list we have here, but we really want every element here to be found in the list of template parameters. What I mean is we are not going to accept construction like I don't know, std base. I don't know if this doesn't exist, of course, but something like that. Or yeah, what I mean is that is going to be the argument now for this base, and this is going to become very tricky to handle, so I'm not handling this kind of stuff yet, at least. For now, we stay to simple bases like this one, where we use the types directly. In fact, I think we have a mechanism already somewhere implemented to check that. When we do the instantiation part here, we are actually checking if it could remap all the template arguments. This remapping is done here, which is for each argument that we get for actual usage case, we check if this name is in the list of mapped type. So if it was, I mean, if this is mapped, so if it was one of the base template arguments. If it's the case, we retrieve the corresponding mapping that we are requesting, and eventually we return the complete new list of arguments. Otherwise, if there's something missing in the process, we return nil. So in this case, maybe you could find an argument name here that would be std base of t. And when you get here, you get this std base of t instead of just t. So you would not find anything, and that would get you to fail in this case. That's why if you don't have this, I just then display a message indicating that, okay, the base class is too complex, we can't support that yet, so we're just ignoring this. Okay, back there. So what should I do? Should I check the compatibility here or not? Not quite, because we don't really need to instantiate this. So if we don't really need to instantiate this, maybe we won't ever have to do it, because we're just defining the class template here, so maybe it's not used at all. So we could just stay with this, adding this as a template and delaying any kind of check that we need to do. But now, yeah, let's get to this instantiate class. You don't want to bring me there, okay. instantiate class with this list of templates. What are you going to do with that? You need to figure out what should be the name of your class. So, well, maybe you should also check that you have the same number of template parameters. So let's do first self. Oh no, you don't have self check. It's just check. Check that the t parameters, the length of t args is the same as the length of self. What is the name of the parameters? Template params. There could be cases where we use default value stuff like that. That would mean a problem for us here, but we'll see if we need to deal with that eventually or not. Next, okay, let me just try to think about that a little bit and then we'll resume the recording. Okay, so I've provided an initial version of this instantiate class. So we would just first try to figure out what should be the full name of the class by using the what we have for the template name itself and adding the list of template parameters that we are providing here. So that would give us a proper C++ name actually. With also the namespaces in front of the class name. Then we would just figure out if we already have a type registered for this class name. And if this is the case with our type mechanism, it means that the target associated to this type should actually be the class object itself. So we just need to return this class object. It's already created. And if it's not the case, that's where we get to the Luna manager and we requested to create this class. This function is actually also taking into account the namespaces and it would, handle properly the case where we have template parameters here for the class name. We could just have a look at this one maybe. It's in the Luna manager, we go there. So it's doing the same thing at the beginning, checking if this class already exists. And otherwise it's handling the case where we have template parameters and it's going to get or create the namespaces and eventually get or create a class with within the namespace. And then register the corresponding type with the full name that we have using this class. So once we have a class created, it's going to be just an empty class and it's always going to be created here because we already checked that it did not exist already. So once we have this class created, we can actually use the exact same function that we are already using elsewhere to inject everything we have for this class template into this class object using those template parameters. And when we're done with that, we just return this class. So this instantiate class now we can properly use here when we know that the scope is a class to create a real concrete class that we can use as base. I think this should already help a bit here because we won't see this anymore. I'm still not quite sure about what this would provide anyway as a result. So let's give this a try just right now. So we request generation of the bindings here for Qt. No, that's crashing. Mismatch in number of parameter. Oops. Integral constant. What is integral constant using as parameters? Maybe you have more parameters. So that would be C++. Actually, no. Wait a second, do you have the right to do things like that? Class T and then T. I guess that's count like a single parameter. Oops. So you can actually have, damn it, more parameters than your template parameters. Okay, yeah, definitely we have a single template parameter for this one, right? I really hope that this is what I'm discovering at least, but I think maybe we should try to check this part. Well, to check it, we can just return some different values here. So you could do display targs. And then different from, and then you can involve the template params. Oh wait, actually that's not where I got the error. What am I doing? The error was for another class, right? No, it's really this one. Yeah, no. Forget what I just said. So we'll get a report of the number of parameters now. What on earth? 2 is different from 4. Are you kidding me? Let's display the full template name. So those template name, we generate them when we create those when we create this template class here. But that template ban, how could you possibly have T0, T1 and T0, T1? Okay, give me a moment to investigate this. Okay, so I just figured out that my parsing mechanism to figure out what are the template parameters is, yeah, it's crap. Because you can get cases, for instance, oh, this one seems okay, but yeah, you can have something like this with a type name, blah, 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 and yeah, it's cut in the middle of it. And it's the same thing here, you have is same, and you have this cut, so the number of arguments here is definitely incorrect. Let's see actually where we get. Of course, if you are starting to provide me a construct like that, I'm going to have a lot of trouble. So which bring me then to the following concern, which is what? How can we parse this kind of stuff properly instead of just relying on the names? Yeah, I was trying to set this as parse because I thought, okay, maybe it's because I'm adding the arguments and then I find this template again and somehow it's parse again. And we have another location where we call this when we have a template parameters here during the parsing. So yeah, but I don't think this is it in the end. It's really that we have a big mess of counting the template parameters. What I could try here is to write the AST again. And I think this is going to fail from my, yes, cast expression. We need to handle this case in get full name, which is in the utils full name, okay. Where is this exactly? In line 179. Method child, okay, so we need to ignore this one. Function template. Whoa. Yeah, sorry, this is a bit of I don't know. Let me just finish that, generate the AST, and then we'll resume. All right, I got the thing running to the end, so the AST should be generated now. Normally I'm storing that in the corresponding binding folder, so we have AST, which is going to be a giant file, of course. Yeah, no. So what I would be searching for here is let's find again this integral constant. So this case, for instance, we know that it's happening here. So we have this kind of structure is compatible bit type helper with a big mess. So let's take that and check in the AST from the beginning. Where do I find this? So we have a template. So we have a base class specifier. in this base class specifier, that's where we have the template.